Looks like we're going to get started here. Hi, everyone. For those of you who don't know me, my name's Kevin. I work at Oracle Labs on TruffleRuby, and looking to talk today about debugging a bit. Before I get started, I do need to inform you that what I'm presenting is research work coming out of a research group and should not be construed as a product announcement. Please do not buy or sell Oracle stock or really any stock based on what you hear in this talk today. So I want to start by going through kind of a common scenario with print statement debugging. So I wanted to come up with something that looked somewhat realistic but also fit on a slide. So here we have a process method that takes an endpoint. We don't know what the type of it is, but we want to turn it into a URI so we can use it with net HTTP and check the error codes and update some kind of database record. So this is your first foray into print statement debugging. The interpreter will provide you with this sort of information with any uncaught exception. And even POSIX codifies it with the standard error stream. So Ruby could just as easily set the process status code to -1 and say there was an error, but instead it tells you there's an argument error. It gives you the line and the line number of where the issue originated from, and then it provides you with the backtrace to help you kind of diagnose it. So in this case, we see it's a bad argument. So naturally, I'm going to add a print statement to see what the endpoint is. Well, now it's not very useful. So again, in this situation, I passed nil, but I don't know what the value coming in was, so I don't know if it was nil or the empty string. So I got to go back and turn that into endpoint inspect. All right, so now I know it's nil, although I guess it could be the string nil, but we'll assume that's not the case here. I'll call it again with a real URL. And now it looks funny because I used P instead of put S. But the exception is different now, so that's good. To simplify things, at this point, I decided I'm just going to go ahead and wrap that endpoint check with a new logger statement. And logging, I think, is just more of a grandiose form of print statement debugging. And it's pretty critical. You need something to kind of monitor your application as it's running. So here I want to inspect the endpoint, add the backtrace, inspect that. This log statement's going to look terrible, but at least the information's there. And because I was seeing an issue with the response code, I decided to just go ahead and pretty print the response. That gives me this mostly useless output. I happen to know that it's a 301 redirect, but if you're just kind of getting started with the API, I don't think the information presented here is the most obvious. So because the error I was seeing came from the response code, I decided to pretty print that instead. Now I'm seeing 301. So now I realize that, the response code is a string, not an integer. So I add 2i on all these. Great. But now I realize that I wasn't handling the 300 series of code. So now I've got all these branches, and I'm kind of simplifying here because usually the branches you'll see come from the callers. And if you're like me and you've been at it for a while, your print statements become gradually more aggressive. So then once you got them all in there, you need to grep for it because your print statements don't actually mean anything. They're just ways to uniquely identify points in the code. So I think this is a good first step into debugging an issue with your code, but you can find yourself in situations where it's really impractical to work with, particularly if you're calling into Ruby gems, because modifying gem code can be really problematic. It's annoying to find it in the first place, but if you're running in a staging environment, you might not have permissions to even modify those files. If you're dealing with native extensions, having to keep putting in printf statements into a C file and then compiling it over and over again can become really tedious. But Ruby does provide a very rich set of APIs for inspecting the runtime. I've put a small selection of them up here. And if you caught the talk on Debuggers yesterday, he gave a pretty good approach to how you could build debuggers based on top of this. But I think the next stage for a lot of developers is embracing debuggers. I don't know. When I was looking up Visual Studio Code, I found this on their website and thought it was kind of funny. I don't really think print statement debugging is a thing of the past, but for a lot of developers, I don't think they ever progress past that step in their skill set. And you can get very far in your career just using print statement debugging. It's really easy. It works in every language. And I think everyone kind of develops their own heuristics and approach to doing it. But I think using a specialized tool like a debugger can be a much richer approach to it. So debuggers, if you're not familiar with them, are tools that allow you to inspect the state of a program and evaluate expressions in it without modifying the source. So in this little screenshot here, you can see a line of code that's being inspected while the program is actually running, and you can see the call stack and a set of local variables. Ruby actually has a lot of debuggers available. The problem, I think, is MRI seems to have mostly deferred the debugger implementation to third parties, and this creates kind of a confusing situation. If you go to rubygems.org and search for debugger, over 100 responses come back. A fair number of those don't actually have to do with Ruby debugging, but it's really intimidating for someone just getting started to know where they should go. And then a lot of the documentation out there on the web is outdated because particular Ruby gems only worked with Ruby 1.8 and Ruby 1.9, Ruby 2.0, and so on. So I think there's a new standard for debuggers that's kind of emerging. And this comes from the Chromium project, and it's called the Chrome DevTools Protocol. Basically, it's a set of instrumentation and inspection APIs used by Chromium-based browsers, and it was designed to inspect JavaScript. What was interesting here is they opted to define a communication layer for it rather than tie the UI directly to the runtime. So you end up with this nice little interaction diagram where the JavaScript runtime is able to talk to the browser through the Chrome DevTools Protocol. But since this is a protocol and that just defines a way for two things to communicate, can we swap out the JavaScript runtime? So I've got a little demo here. So what we've got here is a TruffleRuby program running within using Chrome for this. The sample's kind of simple here, but I wanted to show some different depths to the call graph because you can call basically eradicate stack frames, fall back, and so on. All right, cool. So we can actually swap out the JavaScript runtime with TruffleRuby. Cool. So we have this protocol. Can we swap out the Chromium-based browser as well? As it turns out, Visual Studio Code ships with a debugger that speaks the same protocol. So with no additional effort from us, we now have a debugger that works with 2 different front ends. We can step through these. We can see the call stack. We can roll back. And because TruffleRuby is actually implemented about 50% in Ruby, we're able to even step into core methods that MRI would basically block you from executing, so you get additional insight into how your application is running. I will say there's one slightly odd issue with doing this in Visual Studio Code, and that's that they assume that the protocol end is being spoken to by JavaScript. So while everything works, it tries to syntax highlight as JavaScript, even though it has a .rb extension. Hoping we can work with them to get that resolved. You can even see it here, the file name string.rb, but it typed it as JavaScript. So with the current state, now we have TruffleRuby able to talk to a whole host of browsers that are based on Chromium and Visual Studio Code. And this is all because we were able to just talk through this protocol. We don't have to worry about building out the debugger UI, which is a lot of work that we didn't want to have to take on. In reality, it's not TruffleRuby doing this, it's GraalVM. So GraalVM is a collection of a whole bunch of things. It can be kind of confusing to explain. But I wanted to focus on 3 components. So there's Truffle, which is a toolkit for building language runtimes. It's based on self-optimizing AST interpreters, and it's the first half of the name, TruffleRuby. So it's how we've implemented TruffleRuby. So every language built with Truffle and running on the GraalVM is polyglot by nature. So they are all built from a common hierarchy of AST nodes, so we can mix and match nodes from different languages with one another. And then when the JIT gets to it, it's able to inline all that. And basically we can do cross-language programming without any overhead. And in order to support this polyglot functionality, though, we have our own protocol for doing interop. So one language can send a message to another language to inspect foreign objects and read, write, and execute them. To kind of illustrate this a little bit more, in Ruby we might have a reference to a JavaScript array. We call .size on that. That gets translated to this getSize message, which is part of the interop protocol. And then when JavaScript handles that, it returns a set of nodes that know how to read the size of that JavaScript array. And these nodes just get added into the Ruby interpreter. So, hey, you get debuggers for free if you build with Truffle. Usually when we talk about Truffle and Graal, we talk about performance. And because we use partial evaluation, we say you get a compiler for free. But with language interop, which is a core facet of Truffle, you also get a debugger for free. So I think it's important to note that what we're doing isn't just trying to build the fastest runtime. We really want to build the best environment for a platform for all sorts of languages and give you the tools to focus on providing the semantics of your language without having to constantly reinvent the wheel. So currently with GraalVM, we have interpreters for JavaScript, TruffleRuby, R, Python, and we have a project called Sulong, which is an LLVM bitcode interpreter. So we can compile C, C++, and Rust to LLVM bitcode. And because GraalVM is providing this common interface, all of them have a debugger that comes for free. All right, another demo. Sorry, Dvorak. All right, so this is, again, something of a contrived example, but you can use your imagination. We have this database of languages and their ages. So in memory, I'm just treating this as an array of hashes. And for some reason, there exists JavaScript code that is able to handle this database much better than anything that exists in Ruby. So what we do is we import the JavaScript file, and it's going to provide this find oldest language. What it's going to do, though, is export it as find underscore oldest. So it converts it from camel case to snake case, so it looks nicer when we start running it from Ruby. So polyglot export is part of the interrupt protocol I mentioned. And now we've just transferred control from Ruby to JavaScript and back. From the Ruby side, I'm going to import that exported method, and now I'm going to call it. And this call is going to implicitly make an interrupt method call. So seamlessly, this moved from debugging Ruby code to JavaScript code. As I'm going through this, I used the JavaScript JSON parse method. We got back an array of JavaScript objects. You can see they have the prototype value. And I'll just go through it. There's only 5 of them, so this should go kind of quickly. All right, so now we have the oldest object. Again, this is really a JavaScript object. So now back in Ruby, this handle to oldest is still a JavaScript object. There's no conversion that's happened here. What we're going to do is read the name out of it. And this, again, will implicitly provide an interrupt message to read that property from the JavaScript object. And I'll just hit enter. And it's a little buried here, but you can see the oldest language in the list is Algol 60. So took the JavaScript string value, was able to interpolate it into an existing Ruby string, and then process it through a Ruby IO object. So if you've seen us give talks on this before, and one of my colleagues is giving a talk tomorrow on how we've implemented native extensions, what we do is, as I mentioned, we take the C code and we compile it with Clang to LLVM bitcode, and then we have another language interpreter that can handle that bitcode. So if that's just another language, then maybe we can debug native extensions as well. Don't worry about that command line. This is still kind of early days stuff, and we'll have to make the UX on it better. But so for this, I opted to use Sam Safran's fast blank extension. It's really simple, so it makes it easy to demonstrate the properties here. If you're not familiar with it, it's a native extension to replace the blank method from Rails. He had discovered that this was a bottleneck of some sort in discourse, so he wrote a native extension for it. So we're going to call blank. I'm going to step into that, and here we are now transferred over to C code, and we're able to seamlessly debug native extensions directly from Ruby. One kind of annoying thing here, and I apologize for it, is we recently improved our C extension compatibility by providing wrappers around objects. So when you see this string value here, that's actually the wrapped object. If I go down a level, you can see that it's a foreign object. So this is actually the Ruby string being worked with in C code, and the value is ABC. So similar here, that encoding was null a moment ago, and Now we can see it's UTF-8. So we need to tidy that up and make it, basically unwrap those value types, or the wrappers, really, to make things simpler. But yeah, from here we can just go through each one of these stages. Sorry, I went through that kind of quickly. Let's see. I'll just restart the frame. And that's something you can't easily do with just using the Ruby APIs. So each one of these, I guess, sigils is really a Ruby method call. So your logical OR, calling the macro here, then we do the equals, then we do the not check. So each one of those is a Ruby method call. Get down here. So this is also kind of interesting. S and E, if we were doing this in C, would be the head and tail pointer of the string. We have our own rstring pointer type that represents the string, but they're aware of their native memory address, so they're able to do these pointer comparisons correctly. And yeah, there we go. Oh, sorry, actually had another demo, forgot about. So if we can do C, can we do C++? And this turns out to be a good deal harder. For this, I'm using the UNF extension. So we'll let that load up. All right, so here we can see the extension initializing, creates the UNF module, creates the normalizer class under that, defines methods, and then it starts to set up these constant values to symbols. So just step through this. Then it does the Ruby level stuff. All right, so now we're back here. We can step down to the next level. Because this included singleton, it needs to do some stuff to initialize the singleton instance. And now we can actually get into the normalize method. So hopping around. So form ID, for instance, if we hover over that. Again, it'll show that it's a foreign value, so we created a Ruby symbol here. The value you can see is the symbol NFC. Now the code here basically does like an extended switch to check which type of normalization it'll perform. Then we can follow the virtual call on the pointer, and so on. And it actually printed out ABC and a massive stack trace. So the C++ stuff is still a little unrefined, but it mostly works. All right, so starting to just recap here. I think print statement debugging is a really good first step in the debugging process. As I mentioned before, it's quick and easy. Everyone knows how to do it. But it does have drawbacks. Trying to actually narrow down where you need to be can be very time consuming. You may get there and realize you need additional context. With the debugger, you're able to see all the local variables. You're able to see your method arguments, things like that. You're able to roll back stack traces and so on. I think improving the developer experience involves a lot more than just worrying about performance. We're trying to attack this from multiple ways with TruffleRuby. So much like Rubinius, we implement a lot of Ruby in Ruby itself, which means you can step through and see what your code is doing when you call core methods. We've tried to make seamless cross-language debugging a reality. There's usually a lot of talk about polyglot programming, but in practice it turns out to be really difficult because you have these two foreign things that don't really work well together. And personally, I think being able to debug native extensions directly from Ruby is a really powerful technique, and it's something that isn't easily doable with MRI, where it has this kind of hard break between the Ruby world and the native world. Continuing to summarize, I think debuggers themselves benefit greatly from VM support, but VM-specific support is a lot of work, and you can overfit your support to a particular bytecode or what have you. So Java suffers from this. The JVM has a really, really nice way of debugging. And basically every Java IDE has an excellent debugger with it. But if you're implementing any other kind of language on the JVM, that debugger is not very useful. On the other end, I think Ruby or MRI really delegates too much to third-party libraries. So it's probably still early days yet, but I think if all of the Ruby implementations were able to even just agree on a flag and provide their own backend support for the Chrome DevTools Protocol, then we can take that part of the equation out completely, and then third parties can work on the front ends without also having to solve the backend problem. As it stands, the debugger libraries that do exist tend to only work with one implementation or another, and I think the Chrome DevTools Protocol provides a really straightforward approach for all the implementations to get the same kind of support. Oh, that went through quickly. I didn't do all this work, so that was a slide listing team members. I'd like to thank them for their help, and that's it. Happy to take any questions. Yeah, sure.
For the amazing talk, I'm just wondering what's the performance loss of running C or C++ on Grow VM?
So running in the interpreter is kind of slow. I don't know if you noticed, but initially loading it takes some time, but they should optimize pretty nicely with the JIT compiler, Graal, because the C and C++ extensions end up just being other AST nodes that we're able to inline into the Ruby calls.
Thank you.
Oh, no problem.
So you mentioned in the talk about two things. Like one is using Chrome DevTools Protocol, and another is polyglot debugging, right? And so this might be a stupid question, but so if it can be implemented in C Ruby MRI, then what's the most difficult thing to do you think?
Probably just getting buy-in to do it.
Bind?
Yeah, sorry, getting agreement from everyone to do it. I mean, I guess you could make the argument that it's still a very new protocol, and Ruby looks on a much larger time scale. So MRI would, I haven't actually spoken to the core Ruby team, but I suspect there may be some apprehension about adopting something so early in the life cycle and then having to support it for decades in Ruby.
So you might think like it's possible for third parties to implement a Ruby debugger for Chrome DevTools.
Yes, they can, but I think MRI needs to provide some better tools to build high-performance debuggers. So it may be that the solution here is to solve that problem and then write a Chrome DevTools Protocol adapter around it. And then you get the UI part of it and also the high performance. Because right now in Ruby, it's really difficult to do things like rollback stack traces. And if you call, and basically if you have to materialize all your bindings and all that, it's also very slow. So to a certain extent, I think people don't expect debugging to be a very quick process, but it should be tractable.
Thank you.
No problem.
I was wondering if it's possible to roll back to not just previous stack frame in the language that you're currently in, but actually go back to the previous call that got you into that language.
Yeah. I don't know if I have time, but I can try to show it quickly.
I was also wondering if you could just talk a bit more about the implementation of rolling back stack frames in your particular setup.
So in this case, Truffle, which is the framework we use for building the languages, actually has support for its own stack frame type, basically. So it can handle stack traces and frames. And it can virtualize frames and materialize them. So where am I going? Sorry, I apparently can't do this and talk at the same time. So get back here. So, nope, I guess I broke it. Sorry, it's worth a shot. It should work, but I was just trying to cram some bug fixes in before the talk and must have done something.
Thank you.
You're welcome.
Hey, thank you for the talk. So I have a debugging tool. If I want to unroll the stack in TruffleRuby, is there a way to do it right now without doing some Java or?
We have a built-in implementation of binding of caller.
Okay.
We need to make that work better with requiring the binding of caller gem, like basically swapping out the implementation with our own, but you can actually call all the methods directly on TruffleRuby right now.
Okay, cool.
Hey, so there are some parts of TruffleRuby that are in Java that you can't step into.
No, not currently.
Okay, that's what I thought. Knowing what you know of the existing C Ruby debugging APIs, I mean, how much of this do you think we could just support on top of those APIs? I mean, I agree, and Kennedy, and we're all on board with getting some standard debugging APIs at the VM level to make this easier, so, because it just falls apart eventually. But I think we could do most of this, most of the protocol with the existing APIs, yeah?
Yeah, I think so. Sorry, I struggle a little bit because the debugging ecosystem for MRI is so scattered, so I may just have a failing of my own understanding of the internals, but for instance, bybug is implemented by writing a native extension that uses trace point, and we need something better than that at the very least.
Right, the whole Ruby-debug stack also has a native extension that uses event hook stuff, which is fine, but it's a little heavier than it needs to be for just a debugger.
Right, if you set a breakpoint, now you got to filter every line and do a comparison to see if they match. And
All right, cool. Yeah, we definitely should do it.
all right, I think that's it. Thanks, everybody.